So as Jan said, I will give you a very short history of the SI units, the measurement units that we use in everyday life that make everything in life function. And I will start off by just reminding us of what we mean when we talk about a measurement unit. So I have a very simple example here on the slide. We might make a measurement. We might say that the length of the table is equal to 2 meters. And this has three parts to it, this expression. We have a quantity, the thing we're interested in knowing something about, the length of the table. We have a number 2, and we have a unit meter. And so the meter is like a reference quantity that we use together with a number to give us some information about the thing we're interested in. And these reference quantities or measurement units have been around for several thousand years. And a few thousand years ago, then we see these very early unit definitions. And the earliest unit definitions were associated with parts of the body, the very famous one being the cubit from the elbow to the tip of the fingers. And this was a very convenient measure because everyone has access to their own cubit, but it wasn't very comparable because all our bodies are a different size. Now, the ancient Egyptians solved this problem by enshrining that cubit length in the forearm of an individual. So in this case, the pharaoh. So we have the pharaoh's cubit all of a sudden, and we have a length measure that is comparable, but it's no longer convenient because the pharaoh has to be present for measurements to be made. But the ancient Egyptians solved that as well. They enshrined that particular cubit length, the pharaoh's cubit, in a cubit bar. So all of a sudden we have a measurement standard that is convenient, it's comparable, it's transportable, we can take it to wherever we want to make measurements. The downside is it's not universal. And when I say not universal, I mean that there was no agreement around the world at that time over what a length unit should be or what even the size of a cubit should be. And in fact, this situation persisted for a few thousand years until we get to 1795 and revolutionary France. And it's at this point that we see the emergence of the first metric system. And in 1795, after the first stages of the French Revolution, the French had done away with all the units of measurement associated with the king and the old regime, and they wanted to replace them with units of measurement which they thought had more to do with nature. And they chose for their length unit something called the metre, and they decided that that should be 1/10,000,000th of the distance between the North Pole and the equator, as measured through Paris, of course. And once they'd done that measurement, they enshrined that distance in this platinum bar that you see here. So it's known as the metre of the archives. Similarly, for their mass unit, they chose something called the kilogram, and they decided that that should be a mass equal to a 1 cubic decimetre, we would say 1 litre nowadays, perhaps, of water. And once they'd made that mass measurement, they enshrined that mass in a platinum cylinder, which they called the kilogram of the archives. And this agreement on mass and length units worked very well. And this early metric system gained traction around Europe in particular, but also in some other parts of the world. And 80 years later, it led to a much wider international agreement, so something called the metre convention, and the beginnings of our modern metric system. And so the metre convention was an intergovernmental treaty which exists to this day, and it was signed in 1875 by 17 states who agreed to act in common accord over units of measurement. Initially, just the metre and the kilogram, but that's grown to be all the units we know today. And of course, 1875 was 150 years ago this year, and so it's this year that we celebrate the 150th birthday of the metre convention and the international organisation that it founded, which was the International Bureau of Weights and Measures, whose French acronym is the BIPM. So the metre convention was signed in 1875. In 1889, they issued the first truly international measurement standard. So they produced something known as the international prototype of the kilogram, which was very similar to this. So it's a cylinder made out of platinum iridium alloy, and it was designed to be as close in mass as possible to that kilogram of the archives that the French had originally designed. And they also produced an international prototype of the metre. Again, this was a metre artefact designed to be as close as possible to the metre of the archives. And these were international standards that were curated at the BIPM. And you can see here the international prototype in its safe at the BIPM, surrounded by its official copies. And on the right-hand side, you can see some of the national copies that were given to member states of the metre convention. So member states were given copies both of the kilogram and the metre. And so the picture on the top right there is of NPL's safe, where we keep the metre that was given to us in 1889, metre number 16. And if you were to take that out of its case and look at it, you would see it looks like that picture at the bottom right there. That's actually the metre bar belonging to the United States. And you can see it's got this X cross-section. So these new international agreements on the metre and the kilogram, on length and mass, worked incredibly well. And in 1921, it was decided that the text of the metre convention should be revised to allow it to include more units than just the metre and the kilogram. Now, it took them a while to decide which units that they would like to include as well in their new unit system, and this wasn't helped by the interruption of the Second World War. But in 1960, they formalised their new system, and they called it the International System of Units. And we refer to that by its French acronym, the Système International de Unité, so the SI. That's where we get SI from. And 1960 wasn't quite the end of the story, because in 1971, we added the mole to the system for chemical measurement, for chemical amount. So that gives us, you can see the logo we use here, our 7 base units, as we call them, of the SI, the kilogram, the metre, the second, the ampere, the Kelvin, the mole, and the candela. And they're very important because these 7 base units are the building blocks of any other unit we might need. And I can demonstrate this to you in a fairly complicated diagram, but you can see that on the left-hand side here, we have all those base units I talked about. So there's 7 base units on which the SI is based: the kilogram for mass, the metre for length, the second for time, the mole for amount of substance, chemical amount, the ampere for electric current, the Kelvin for thermodynamic temperature, and the candela for luminous intensity. And from combinations of those base units, we can make any derived unit, we call them derived units, any derived unit that we need to make any type of measurement we can think about. So some of these derived units are very simple. You'll be very well aware of them. Meters per second for velocity, they're very simple. We tend not to give them special names. Some of the derived units are much more complex, and we tend to give them special names like joule for energy and so on. So taken together, the base units and the derived units are all we need to express any measurement we can think of. So I mentioned the metre convention. It was signed in 1875. It's since become a truly global agreement. So you can see all the member states in green on the map here, and they cover 98% of the global economy. Now, there are countries there that are not members. They're in grey or red. There's no doubt that they use the SI. They clearly do use the SI. It's just for whatever reason, economic, political, or organisational, they're not able to join at the moment. But all these countries around the world who are members of the metre convention, they are very keen to improve the system and constantly develop the unit definitions that we have. And so from 1960 onwards, there's been a great effort from the metrology community to improve these SI unit definitions. And you will remember that these very early unit definitions were based on these physical artifacts like this. Now, these were very convenient to use, but they're also potentially damageable, losable. So they're not ideal, and in many ways, they're the least stable way we can define a unit. So since 1960, metrologists have been looking for better ways to define the units that we base our system on. A better way to define a unit would be to define it in terms of a material property. So the image you see there is of a triple point of water cell, and this used a temperature very close to the freezing point of water to define the temperature scale using a material property. But ideally, we want to define our units using fundamental constants of nature. So these are the most stable things we know about, the best things that we could base our units on. So the example given on the right there is of the speed of light. And so since 1960, it's been the desire of metrologists to move all of our unit definitions from physical artifacts to material properties and ultimately to fundamental constants. And indeed, that desire was achieved in 2019 at something called the General Conference on Weights and Measures, a picture of which you see in the background there. That's a big meeting that happens every 4 years and decides on changes to the international system of units. And they decided to redefine all the units based on fundamental constants. And so we'd moved from this situation in 1960, where we had our logo just with our units, to a situation in 2019 where we have this new logo involving our units and the fundamental constants that we consider the definitions in terms of. And so that really, in a nutshell, is our SI, our fundamental constants, our base units, our derived units. Also, as Joanne mentioned, the SI prefixes are a very important part of the SI. I haven't mentioned those today, but we use them with our units as our measurements get very big or very small. So the SI really is our only globally agreed unit system and is an essential part of modern society. So that's a very quick run through of the SI units. If you're interested in a longer talk that I gave recently, you're welcome to scan the QR code or use that short web address. Thank you very much.